Hi, it's Jan Beta, and today we're going to take a look at the Amiga 500 power supply from the previous episode that didn't quite work as expected after recapping and refurbishing it. So here's the power supply in question that I tried to do some retrobrighting on in the previous episode, and I also replaced all the electrolytic capacitors in here. This is a November 1987 Amiga 500 power supply that allegedly came with the early Amiga 500 that I've worked on in previous videos. This is one of the early models of these, which has 2.5 amps on the 5-volt rail. It's kind of a hybrid between a linear power supply for the 12-volt rails, plus and minus 12 volt, and there is a very simple switching power supply rail for the 5 volts to provide the higher output that is needed on that rail. I've looked at this power supply some more off camera, and I actually tried it with this crystal clear Amiga 500, which has a revision 6 board in it. And while it didn't power the Amiga 500 with the revision 3 board, look at this. This just starts up fine without any issues with the power supply that wasn't able to power the Rev 3. So my assumption kind of is that the newer board revisions require a bit less power actually, and this is enough to power this. I've also tried a revision 5 board that was powered fine as well. The only thing that isn't powered correctly is the Rev 3. So we're going to have to take a look at this power supply, I guess. I think there's something marginal in here. Yeah, maybe this is a good opportunity to take a look at these power supplies because they are quite interesting, old school switching power supplies with a linear portion. So I dug out a schematic for this, which somebody provides on GitHub, thankfully, for these early power supplies. I have some spare parts from my own old power supply that I salvaged that we can try in this one. We're going to try to figure out what the trouble is with this power supply. Let me take a couple of seconds to thank the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype PCBs. They also do CNC machining, sheet metal fabrication, 3D printing, you name it. All the products a tinkerer needs produced, they can offer. The prices are very reasonable, delivery is fast, they are friendly people to work with. I highly recommend checking out the link in the video description. Back to our power supply. I now hooked up my Rev 5 board, which is actually broken. It displays a yellow screen last time I tried this, to this power supply, and turned it upside down so we have access to these points where the power connector connects to measure the actual voltages that come from the power supply under load. So this is basically just a glorified load because it doesn't work. It's not a working Amiga 500 board. That's something I want to fix in another video at some point. But yeah, this should power up because I tried and it powered up to the yellow screen that this board produces with the power supply. That didn't power the Amiga 500 Rev 3 at all. It didn't even light up the power LED or anything like that. So something is pretty marginal with this one. We are going to figure that out. So this one should fire up to a yellow screen. At least that's what it did. Yeah, something like that. It's a, I don't know, cyan colored screen in this case. This isn't working, but the power LED is lit. This board doesn't quite power up correctly because it is a broken board. But we are going to have some load on the power rails here, so that's the main purpose of this exercise. Okay, let's get some voltages. I'm just using this ground here next to this. And this is our 12 volts rail, that's 11.6. That is a bit low, but it's going to be okay. That's our minus 12 volts rail, that's pretty much spot on under load. We had a minus 16 or thereabouts reading without a load on this power supply. Yeah, this is the 5 volt rail and it's at 4.95, which is technically okay for powering an Amiga, but if the voltage if the current draw on the Amiga 500 Rev 3 is a bit more, this will probably go lower. We measured 5.1 volts on the connector without a load. And these are our 3 voltages under load. Yeah, so the 12 volt rail is pretty much okay. Plus 12 is a tiny bit low, but that's still okay. The 5 volt rail, I suspect the 5 volt rail, something's wrong with this 5 volt rail. Yeah, the 5 volt rail is the most important one by far, and that's the one that has the switching power supply portion in this power supply to provide enough current to actually power an Amiga. I think the 4.9 thereabouts we got on this Rev 5 board is actually in spec, so that is going to power any Amiga fine. But it is a bit low considering that we had 5.1 volts on the connector without a load. So it should be pretty much straight up 5 volts, and it might be that the Rev 3 board draws enough current to bring that down to 4.8 or something, and the Amiga is not going to be able to start up. The 5 volt rail powers all the chips. The only thing the 12 volts is used for basically is expansions and the disk drive motor and also the sound amplifier. There's a differential amplifier chip in the audio circuitry in these Amigas, and that uses the -12 for 1/2 of the differential amplification and the +12 for the other half. So those voltages are not really needed to power up the system. The 5 volt rail is the one that is powering everything basically, including the power LED. So that is the one we are going to have to take a look at, I guess. I unplugged this and I'm going to have to open it up again. The Amiga 500 Rev 3 worked fine with another power supply, so maybe something's wrong with this. Even though it powers the other Amigas, I tried fine. So there we go. It's all nice and clean at this point because I cleaned it in the previous video. I'm going to take the whole board out to be able to work on it. That is held in with these 2 screws, and there's another screw here. And then you can carefully, because these boards are thin, carefully lift it out. That's what I'm going to do. And there's no high voltage switching power supply in here, so all the capacitors are low voltage capacitors. I think the highest voltage capacitor in here is 25 volts, so we don't risk getting shocked from those, thankfully. It's easier to work on than modern switching power supplies, which usually use a very high voltage rail to be able to produce the output voltages. So yeah, as you can see, there's not a lot of components in here compared to other more modern switching power supplies. We basically have a huge transformer. We have, of course, we have a fuse. We have some mains filtering capacitors that are basically responsible for filtering the noise that the power supply, switching noise that the power supply creates. These are filtering that from going back into the mains. We have some electrolytic capacitors that are very prone to failure in these, especially since they are old and this is a power supply and runs pretty warm. We have a switching transistor that is this on this heatsink here, and we have 2 voltage regulators. Here's one and there's another one for the +12 and -12 volt rails. We obviously have some rectifier diodes. This is the bridge rectifier in a little package here. We have a coil to filter some noise, and we have a couple of auxiliary stuff. This chip here is the most important chip for the switching portion of this, in conjunction with the transistor. This is basically just used as a power amplifier transistor. It's a high power NPN transistor, I believe. This is a PWM chip, so that is responsible for switching actually, which generates the 5 volt rail. And this is a 3524BN chip, which is a general purpose PWM controller chip, which in this case is used for the switching portion of the power supply. This transistor is a D45H11. So these 2 things are my main suspects. at this point, because sometimes if these chips get a bit weak, they are not going to produce enough current for the power rail to have enough juice. And also the transistor, of course, can break and can be tiny bit weak. And these resistors here, which are two 180 ohms resistors in parallel, so we measured 90 ohms across both of them. Resistors in parallel, basically you get 90 ohms if you have two 180 ohms resistors in parallel. These obviously, as you can see on the back side here, they run really warm. So I think it's a good idea to replace those and stand them up from the board slightly. And I bought some a bit higher wattage. I think these are half watt or quarter watt even resistors originally, and they are just doubled up to withstand some more current. So I'm going to replace these with higher wattage models basically. And I think I want to remove the chip and I want to remove the transistor and have a look at those and see if those work. Both of which I have replacement parts for from my power supply that I broke a while back. Those components should still work fine though. So my spares will be good replacements for these. And to replace the resistors, I got 2 watt versions, which are much over the top, but we should be able to fit these in here fine, and I'm going to stand them up a bit so they don't run as hot. These are prone to fail, obviously, because they are hot all the time, basically, while this is running. The bridge rectifier thingy, I also have a replacement for that. That is also a standard part, TLS 1074. And I have a similar one. I think it's another part number, but it was the same power supply design that I took these parts from, so should be good. So I'm going to desolder the chip. I marked the pin 1 with the little red dot on the board. I'm going to desolder the resistors. The chip is my main suspect at this point because these can be responsible for all kinds of issues with these power supplies on the 5-volt rail. And the resistors also are going to have to go. Possibly I'm going to check if this charred backside here became conductive in the meantime, which also happens if these this basically turns into coal. So that would be carbon, and that would become conductive in the worst case. So that might happen. Doesn't look that bad. I've seen much worse on these power supplies. But in the worst case, we're going to have to cut this a bit in the center, which is probably what I'm going to do as a precaution anyway. Let's desolder some stuff here and try if we can make this work again. I mean, it does work, but it's marginal. These are super easy to work on because single-sided board, not very thick. So let's see if we actually have conductivity. No, not really. That's good. Probably still going to cut a bit of this or scrape it off at least, because that could very well become a conductive layer in the future. I'm just going to scrape some of this off. Guess that should do. Could also, in the worst case, just cut a slice here or drill it out or something. Because as you can see, even underneath the surface there, I scraped away the solder mask basically. You can see the brownish spot in the middle there. Inside the circuit board actually. That could be conductive, but it isn't in this case, which is good. So we're going to put the new resistors in there. So I think first of all I want to put a socket in here and then put the new resistors in after checking the old resistors, I guess. That would be a good idea. So the old resistors should be 180 ohms, if I'm not mistaken. Yeah, 179.2 is this one, and the other one should be very much the same, 180.1. And these are 1% tolerance parts, so that is all perfectly in spec. Let's see if our new ones live up. These are also 1% metal oxide. Okay, that's a bit more than 1%. Should still be good enough for the purpose. I'm just going to take 2 of those and put them in there. But first, let's put a 16-pin dip socket in this position here with the cutout facing in the correct orientation, which is this facing away from the rest of the components. It's probably not the best idea to have socketed chips in something that vibrates because there's a huge transformer in there. But these turned pin sockets are usually pretty solid, so the chips are held in there pretty well. Okay, let's drop in the spare PWM chip I have from my old power supply, which I guess might be the issue here. We're going to find that out. So there's our chip in. I'm going to temporarily put it back in the case so I don't risk zapping myself, because this is a mains powered device and we always want to be super careful with those. Just double checking the resistors here. We should have 90 ohms or thereabouts. 88.8. That should be close enough. Okay, I plugged this back in and I'm going with my Ref 5 board here again to see if anything blows up. I hope it doesn't. Let's see if we still get reasonable voltages here. This is our 12 volts, which is 11.7 now, which is okay. Minus 12 is still minus 12. And that's 5.03 volts. That's much better than before, actually. This might even be enough to power our Ref 3 board. So here's the revision 6 crystal clear Amiga again. Let's see if it powers that. And indeed, it does. Now I think it's time to see if it also powers the Ref 3 Amiga. I am going to leave this on for a while though to see if anything runs away or gets overly hot. We should probably be good. So I actually left this running for a while with this Amiga and nothing gets overly hot or anything. No bulging caps. I think this might be fixed. Let's try with the revision 3. So, same perspective, but this time with the Amiga Ref 3 that this is supposed to power. Actually, let's see if our replacement chip did do something. And it's still not powering this one. For whatever reason, it's still not doing anything with this. Nothing. Not even the power LED comes on. What's going on? Is there something that draws so much current that this doesn't power up? It is a working Amiga power supply, from all I can tell. Maybe the voltage is still too low. So yeah, I went on and removed the RAM expansion from the Ref 3. We still don't even get the power LED to light up with this power supply. So something's still rotten there. That is kind of strange. So yeah, I'm going to take this out again. And I think the last resort, at least the last thing I can think of, is to replace the transistor, which should also be responsible for the switching going on there. So I'm going to take that out and put the known working one in that was in my original power supply, my Amiga 500 power supply. Maybe that works better. We're going to see. Not sure what else I can do. The rectifier could also be an issue, obviously. Oh, and maybe this diode here. That's a bit low of a voltage. We should remove that diode and give that a proper check. So this diode here also measures a strange voltage. That's a bit too low for my taste. And this is a D45H2, whereas the replacement one is a D45H11. And it's also green. Maybe that helps, I'm not sure. So I'm just measuring these in my components tester here. This is the replacement part from my working power supply. It's a PNP transistor actually. So let's note down those values, I guess. And then we are going to check the other one. These are riveted to the heat sinks, so it's not easy to test them because I don't want to remove the rivets. Yeah, that's basically the same, so that should be good actually, probably. I'm still going to put the green one in. That's basically the same measurements here. So they are probably both good. might still be marginal. The component tester basically doesn't measure those under load or anything like that, so that may still be an issue there. And we're going to retest this. Nope, still nothing as expected, because the transistors seemed good. That is strange, to put it mildly. Sanity checking with my known working power supply here. Yeah, that's more like it. So the Amiga is okay. It's still the power supply for whatever reason. It doesn't produce enough juice to power this Amiga. Maybe. So I desoldered this 1N4001 diode that gave me a strange forward voltage in circuit, and it should be around 0.7 or 0.6 volts. And yeah, that's actually good. So it was measuring the wrong forward voltage because there's a resistor in parallel with that 47 ohms resistor, this one here, which is very spot on 47 ohms. So that's all good. I measured some of the smaller components in general, and they all seem to be okay. So I'm not sure why this doesn't power the Rev3 Amiga still. So I looked at the schematics. This is our diode, and it actually specified a N4003 diode, which is basically the same as a 4001, but it has a higher blocking voltage. So I think the 4001s are 50 volts and 4003 is 200 volts or something, both of which are way over the top for this purpose. I'm still going to replace that diode just because I have a stash of 4003s in my parts bin. We're going to take another look at the capacitors maybe. Maybe the ones I put in there are not the correct ESR value or something like that, and it starts oscillating. Probably going to take a look at the 5-volt rail on the oscilloscope to rule that out. Other than that, we can also replace our little rectifier that's in there, or rectifier module. I have that spare. Not sure what else to do. I'm pretty much stumped. This is our little rectifier module here, basically a diode. A glorified dual output diode. We're going to take a look at that, and then I'm pretty much out of ideas. So putting the 4003 diode in there. Obviously should go into the same polarity as the original one. Maybe the oscilloscope picture is going to tell us more. Or maybe the Amiga has an issue still that I didn't find. But why would it work with other power supplies? I'm not sure. It's kind of strange. Yeah, let's try with the new diode in. Nope. Not at all. I'm going to hook up the broken Amiga 500 as a load and have a look at the oscilloscope, I think. So I hooked up the ground to the ground on the power supply, and I'm going to measure the separate voltages here and see how much ripple we have on the voltage rails. So yeah, that's around 170 millivolts on that rail. That is a bit high, the ripple, but still should be nothing to worry about. You can see the millivolts, that's the peak to peak. Ideally this would be a line, so straight DC voltage, which it isn't because it is a switching power supply and there's noise and ripple in all those rails. Usually the ripple on a good power supply is something below 100 millivolts. So these are a tiny bit high, but nothing to worry about really. And we're still at 5.04 volts on the voltage rail that we are concerned with. So yeah, that seems to be all good really. The ripple is a tiny bit high, but as I said, 120 or 170 millivolts or something like that's nothing to worry too much about usually. Maybe let's compare this with my known good power supply and see how that works out. So here's the power supply, the more recent power supply, which has a higher frequency switching power supply in it. That's a couple of megahertz there. And we also have a tiny bit lower ripple That's also not great. It's fluctuating quite a bit, but yeah, that's 100 millivolts or thereabouts. So maybe that difference is enough to make the Amiga Rev 3 not take it. That might be the issue here. So I think what I want to do is to replace this rectifier package here, and maybe also take a look at this capacitor here, which is the output filter capacitor. Maybe we have an issue there. I'm just going to replace this, I think, and then just for giggles put in the old filter capacitor here. Maybe the ESR rating is different on that one and this doesn't filter as effectively. I'm not sure. I'm extracting the rectifier package, and these are also slightly different part numbers. This is the one I just extracted. This is a TL-S107.4 and this is a TL-106.4. So yeah, slightly different part number. Should be completely compatible, just probably different voltage ratings or something like that, which won't matter much because we're at a relatively low voltage here. Anyway, so let's solder this one in and see if that makes any difference. Yep, that should be in. Yeah, and that's pretty much the same result, around 180 millivolts to 200 or something, and that's definitely not very good. So we should try and replace that output capacitor there, I think. Probably, maybe that's not filtering enough. There we go. Let's measure this against the original capacitor, I guess. So here goes the new capacitor, which has an ESR of 1.6 ohms. And it's a bit over its capacitance, which is perfectly okay for a brand new capacitor. Let's see what the other one says. Yeah, that's the same ballpark, so not much difference in these at all. As I said, these are not very low ESR or anything like that. This is pretty worn out as well. That shouldn't be any different, really. And this is a 6.3 volts capacitor and this is a 10 volts capacitor. I'm still going to put the old one back in just for testing. Maybe something else is off. I'm not sure at this point. As you probably noticed. And if I'm not mistaken, we shouldn't see any significant difference at all. Yeah, that's exactly the same. 180. Yeah, same, I think. Let's see if it powers the Amiga. It powers this Amiga, as it did all the time, basically. Okay, Rev 3 Amiga is hooked up again with the old capacitor. In there again, let's see if that makes a difference. No dice. I don't know why this Amiga doesn't power up with this power supply. Maybe the ripple is too much, but I'm not sure how we would get rid of the ripple. The other capacitors are not very high frequency or anything like that, so it should be okay with those general purpose caps in there. And everything else I replaced except for the voltage regulators. And those are not responsible at all for the 5-volt rail. So yeah, And all the components I measured, the smaller ones, are perfectly fine, so there's not much that can go wrong there. Plus this powers other Amigas. I'm not sure what's going on. It does work with everything but the Amiga we want to power with this. That's kind of disheartening. And it does work pretty well. I don't get any flicker or anything like that, which could be caused by a power supply that's not quite on par. Picture looks excellent, crisp and everything. Not sure. Yeah, at this point I'm pretty much out of ideas. This should technically, it provides the correct voltages. The ripple, as we've seen, is a tiny bit high, but that shouldn't really be a problem, I guess. Maybe it is for the Rev 3 Amiga. This Rev 6 and also the Rev 5 did power on, no problems whatsoever. And I had this running for several hours with this Amiga, so it definitely powers Amigas. just not the one we wanted to power with it. If you have any ideas how I should go about trying to figure this out, please leave them in the comments. I'm not particularly a professional with power supplies, as some of you who are have probably noticed. I don't recommend you do any of the things I did, because I'm clearly not the right person to try and fix this. Still not sure what causes the issue, as I said repeatedly now. I hope someone in the comments knows a solution to this problem. Otherwise, I'm just going to leave it at that and write a little note on the power supply that it works with all Amigas I've tried, but not with the Rev 3 that it came with. Hope you enjoyed this anyway. Can't always be a win, I guess. Thank you so much for your support on Patreon and on the channel memberships page and on Ko-fi, and also for your subscriptions. I recently passed 50k, which is kind of amazing given what I do here. So thank you very, very much. Hope to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.